So this is take 4 to explain this problem. I don't know how to use all the tools really well on this laptop, so I'm having issues. But okay, so I'm doing number 8 in your worksheet for today. And excuse me, and there are 2 parts to this problem, okay? So there's this part here that you're asked to evaluate using the limit definition. And then there's the other part which is to check by integration, okay? So the blue part really is dependent on this formula that's in the summary worksheet. Excuse me, it's this one here, okay, that I've made corrections on and that I sent the summary sheet to you today. So it's based on this formula here. And let me just go rewrite that, okay? So an integral fx dx from a to b is defined as the limit as n goes to infinity of sigma I equals 1 to n f of a plus I delta times delta, where delta is equal to b minus a over n. So that's the basic definition of the integral using the limit definition. So the problem we have here, we need to split this up into 2 pieces, okay? So there's one piece that is the 9 t squared from minus 4 to minus 1 dt, and then there's the other piece which is the 5 integral dt with the same limits, okay? And I'm going to work on this problem separately. Noticing that delta is going to be b minus a, so b is minus 1, a is negative 4 over n, so delta becomes 3 over n, okay, for both the integrations, okay? So let's do the blue one first, okay? So the blue one's going to be, so I'll just call it I, standing for the integral, is equal to limit as n goes to infinity of 9 sigma I equals 1 to n. And in this definition, f is t squared, so all I need to do is put in negative 4 plus 3i over n t squared. Notice that in this formula, a is the lower limit, which is negative 4. Delta is 3 over n, and I is I. Okay, so that's the blue integral, and that's all I'm going to work on. And we have times 3 over n. That comes from this delta here, okay? So if you fold this stuff out here, fold this guy out, this becomes limit n goes to infinity of 9. And if I fold this out, this becomes 16 minus 24 I over n plus 9 I squared over n squared times 3 over n. Okay? And now what we've got to do is we've got to use the formulas on page 260. They're also in the summary sheet, so let me go show you where they are in the summary sheet. They're right here, number 7. Okay, those are the formulas you need. Actually, you will need only the first one and the second one. You don't have an I cubed in there, okay? So you should really know those formulas, although you know you're allowed to bring in the summary sheet, so feel free to use that. So this becomes limit n goes to infinity of 9, and the sigma sign is now going to be replaced by those formulas, okay? So I'm going to have 16n minus 24 over n times n plus 1 all over 2 plus 9 over n squared times, let's see, what was that formula? N times n plus 1 times 2n plus 1 over 6, and everything is multiplied by 3 over n, okay? Which then becomes limit as n goes to infinity of 9. And now I'm going to pull this 3 over n inside, okay? So then that becomes 48. And the next term becomes 72 n times n plus 1 over n squared. This n times n gives you n squared, plus 27 n times n plus 1 times 2n plus 1, and downstairs I have 6n cubed, which comes from 6 times n squared times n, okay? And so now coming out here, I get that this is all equal to, and remember that what you're doing here is you're finding the limits as n goes to infinity, which really means that you need to know those three rules that I keep talking about all the time. Hang on, let me see, where are we? Okay, did I F up somewhere in here? No, that looks okay. That's 9 times 48. Okay. So the limit definitions that we want as n goes to infinity are going to look at the degree of the numerator versus the degree of the denominator. So the first one, it becomes straight 48. So this guy becomes equal to 9 times 48. The next one, the highest degree upstairs is n squared. Downstairs is n squared as well. So that doesn't change anything. And that, sorry, there's a 2 here. That's this 2 here that I missed. And so that should be minus 36. And for the last term here, the degree upstairs is n cubed. Downstairs is n cubed. So that means it's 27 times 2 over 6. And so the 2 and 6 cancel to give you 3. And 27 and 3 cancel to give you a 9. So that's plus 9. Okay. Let me make sure you guys know which rules I'm using to do this. So I'm going to go on my website, show you where all that stuff is, okay? I believe it's in chapter 3, summary. I'm going to go open that. And the rules are here, rule number 10, okay? That's number 10. So again, you're allowed to bring in all the summary sheets for your quiz and your test and all that, okay? So trying to really take the load off your memory to memorize these things, but that doesn't mean that you don't need to know where these rules are. Obviously, you need to know where they are, okay? You might not need to memorize them, but need to know where they are. So then this blue integral now becomes 9 times 48 minus 36 is 12, plus 9 is 21. So that's 189. Okay, so that's just for the blue part here. That's this guy here. Okay. So now I'm going to work on the red one in a very similar fashion. Okay. The only gotcha here is that f is just 1, so there's nothing to plug into. So the red integral now becomes equal to limit as n goes to infinity of 5 sigma I equals 1 to n. And like I'm saying, since f is 1, there's nothing to plug in. All I have is 3 over n, which then becomes equal to limit n goes to infinity of 5 times 3 over n times n. So the n's cancel, and that's equal to 15. So my final answer for the limit problem, which takes